Hi, welcome to this Open Security Summit session in December 2024. And we're going to have Petra, which is a long-time contributor, one of the great, I would say rising star talents, but you're already quite up now. So it's you're less rising, but like already
I
super.
hope I have risen.
Yeah, you keep going. And but we're going to talk, I think, which is a really cool topic, which I think now that we start to use Gen AI more and start to understand where it works, where it doesn't work, and I think there's a lot of hype, but there's also a lot of great use cases. We're going to start to say, are we finally on the verge of a big breakthrough? I think yes, absolutely. But I'm going to let Petra, you know, start with her views of it.
Cool. Yeah, here we are, the big buzzword AI. I appreciate you guys joining. Let's have a chat as I go through the presentation. Feel free to interrupt me, make comments, make questions. Let's make this discussion.
Well, actually, on that one, I think it's important that we separate what is machine learning, which is kind of what we've been doing for the last.
Okay, I have a slide on that, Dennis. Don't ruin it. Don't ruin
Cool.
it.
Perfect. Perfect. Yeah, no,
I
because I
have
think
a
that's
slide.
important. Because that's a big distinction. Okay, go for it.
Yeah.
All right.
So, very sorry. Need to go. Why is it not?
Yeah, that's it.
Wait. Okay, who am I? Um, I used to be a doctor, but now I'm head of information security in Newman. I'm a technology enthusiast. Do a bit of public speaking. I am also a machine learning enthusiast. I started my security journey in Glasgow, and this is where I even kind of created a little threat file risk detector based on machine learning, which now has a patent, which I'm proud to say. And yeah, moved on being a security engineer, became a director of cybersecurity in job and talent, and now I'm head of information security in Newman. So threat modeling has always been my passion, and that's kind of why I'm here today to talk about threat modeling. So yeah, I'm going to talk about what is AI. I'm going to talk about the current state of AI in cybersecurity. I'm going to talk about the potential and some of the basically limitations and challenges that we have when discussing AI. And sorry, my setup is weird.
Yeah.
Okay, so what is AI? This is kind of something that Dennis wanted to clarify straight away, because as time went on, whenever we talked about AI, it was always a different conversation. There was the concept of machine intelligence actually came from Alan Turing, and essentially, he defined it as the ability of machines doing human actions and human work. And that's kind of where this concept of machine intelligence came from. Now, after that, actually, also just to mention, because I do have the images um, from a famous movie. Anyone recognizes it? I guess that's a no.
I do, but sorry, can go for it. Is hackers? No, it's not.
Oh,
Which
no,
one?
it's a Blade Runner. And basically, what Alan Turing did is he created a test to see that would differentiate a machine from a human. And the test depicts of you have someone who is conducting the test like a person, and then you have a machine and a person answering it. And you have to see which one is which. And then later that was also depicted in the Von Kampf test in the movie Blade Runner, which is kind of depicted here. So moving on, after Alan Turing, we had scientists become really, really excited about neural networks and essentially the concept of making machines think like the human brain, creating networks that were actually similar to, the brain synapses. But there was a big limitation, and that was computing power. So, you know, machine the computers were big as building blocks. So there was no progress there. That's kind of where it ended, the excitement. Then later on, back in the 90s, we came into the big era of deep learning. Deep learning was something that actually came after machine learning. And machine learning was actually just glorified statistical models on steroids. And what machine learning enabled is actually machines or computers to make decisions. And initially, when everyone talked about AI in the last 2 decades, it was mainly meant around machine learning. That's kind of what people meant when they talked about it. So machine learning was really good for predicting outcomes in terms of finance. It got used a lot by Netflix and Spotify because it could predict the preferences of a user. So Netflix and Spotify actually made a lot of money on that. And then we entered the era of deep learning. And deep learning is kind of like the comeback of neural networks, where we actually took vast amounts of data and tried to kind of make sense of it, tried to make some algorithms and neural networks that could create decisions, but that could also recognize images. So also autonomous vehicles started in this era when we had the deep learning era. And then we're reaching nowadays in the last 2 years, we are reaching the era of LLMs. It seems like it's been years, but actually, we'd only started this new era of LLMs. Now, when we talk about AI, we don't talk about machine learning. We don't talk about deep learning. Now everything is about LLMs. And even at the beginning of the year, ChatGPT passed the Turing test. So now we're kind of like reaching this uncanny valley where we can still see the difference between AI and humans, but we're kind of in this uncomfortable zone where we're like, oh, it's too similar. So moving on. This was the little kind of depiction of what AI is. So when we talk about AI, usually in cybersecurity, there's 2 things we talk about. We talk about LLMs, but we also talk about machine learning, because machine learning has actually helped us a lot. So what do we usually, what is the topic around AI these days? If you ask ChatGPT, it will actually tell you mainly the theme is negative, because in security, we're very paranoid, and which is good, this is why we're good security professionals. And but then, it goes a little bit dark and doom and gloom, because we tend to talk about all the privacy implications of AI, all the security implications of AI. We're worried about prompt injection. We're worried about data leakage, poison models, attackers utilizing it. And then we enter these conversations of mistrust, like, should we allow it to make decisions for us? It hallucinates all the time. I mean, we even started a conversation talking about hallucinations. We don't trust it to automate the whole end-to-end workflow. But then also we do, like, today, and like, Dennis talks about benefits of AI, and where we establish those benefits a lot is threat detection and a lot of automation with like man in the loop. So I'm going to talk a little bit about that, where we actually establish this usage and where we actually do trust it. So threat detection, we trust it to, detect phishing and spam. We trust it inside our EDRs for malware detection. And we also trust to detect fraud. Like, a lot of banks are using these days AIs to detect fraud. So we can see that machine learning especially is good at predicting patterns, and is good at language, for example.
A lot of the ones you have there at the top, wouldn't they fall more on the machine learning side than the
Yes,
side?
they do. That's why I said, so mostly machine learning. And we trust it to kind of recognize patterns. And that's like a very specific thing that machine learning does, that it's good at, and that we recognize it and then we trust it. So absolutely, the top is definitely machine learning. Phishing and spam nowadays is used more, LLMs are more used than machine learning. We had before, like, natural language processing algorithms used for phishing and spam, but nowadays it's like a lot of it is LLMs. So we do trust it to automate. We do trust it to give us some remediation advice, as long as we have a man in the loop. So we do trust it to do some containment actions in SOARs. We do trust it, for example, in cloud security posture management, to give us a Terraform template, how to fix something. but we do actually have a man in the loop. We don't trust it fully here. And then also, in risk assessments, there's a lot of tools who started using, again, machine learning mainly for, predictions and forecasting and risk quantification. So these are some of the usages where we can say, okay, AI has really established itself. Some of the things where AI is kind of evolving, but is really getting there, and we're learning to trust it more and more. It's one of the things is vulnerability and threat prioritization. So we're trying to, in vulnerabilities and even threats, the prioritization is so important. And here is what AI does, is connects the dots and provides us additional context. Penetration testing. So we have tools that are being used in terms of creating some attack trees and then creating an actual penetration testing scenario based on those attack trees. And then we have tools like verge GPT, which intercepts requests and then uses AI to help us actually do the actual pen testing. And then we also have code scanning, where we have, static code analysis is now being enriched with the AI algorithms and is being used by the biggest players. And nowadays, we're starting more and more to use it in security reviews and threat modeling.
So can you go back one? I think you missed one, right? And to be honest, is one that is very dear to me, because I think I sit kind of in the middle of two camps, which is the development camp and the security camp, right? And I think I can play quite well the intersection between both, right? It's a bit like when I'm a CISO and a CTO, right? I can, but also, I feel that one of the biggest challenges in AppSec, right? And I think not just gave us a credibility problem, but also is a fundamental problem, is that every single AppSec problem is a development, a DevOps, is an engineering problem. Every single one of them, right? Now, I think we're very good at it. I think we have a massive part to play because, like you said, we see things a bit differently. I actually would argue that these days, not only want to bring people into the AppSec industry from other areas, like you came from medicine, I think we need to start sending people from AppSec into other industries, because I think there's a way you think about things, there's a way you question things, there's a way you look at 3 dimensions that is very valuable. But my point here is that I think that one of the biggest flaws in AppSec was that the way you do AppSec is you fix development. In a way, you make AppSec by almost not needing AppSec. And the only way you do that is you need to engineer out, right, all of the AppSec requirements. And I actually feel that, AppSec, a lot of times exists because there are so many gaps in the development process, right, that are broken. And then, and we kind of see the side effect of that, right? So I think one of the areas where I think, especially Gen AI, and because the way it works, it's not to automate stuff, it's not to have agents, and agents will have a play, but it's not to have like that kind of press a button and do stuff, is to help us understand reality, to help us to create development environments that are way more productive than what we have now, right? And I think if you look at a lot of challenges we have in AppSec, if we get better visibility, if we have better data, if we can have better transformations from A to B, everything else becomes so much simpler, right? So I think, even on the examples you have here, like most of these things is ridiculous and productive because they don't have context, right? Because they don't have good information, don't connect the dots. Well, what I think the Gen AI can give us, especially Gen AI, because Gen AI has an intermediate representation internally that can do this, the Gen AI will allow us to start connecting the dots. And I think the key part there is that we will be able to do that without having to code everything. Because in the past, again, every tool here had the problem that they couldn't scale because every app is different, every framework is different, every version of the framework is different, right? And you could not deal with all of the variations. So eventually you have something that doesn't really work in the real world, right? So the one I would add here is allowing us to understand the code, the infrastructure, the connections, basically this gigantic graph that is our apps, which we never had before at scale.
Yeah, I agree.
And if you do that, everything here becomes more effective.
And I think what you said, I'm going to touch on later about automation. Like we, as engineers, tend to, a lot of times, want everything to be automated. But I think some of the bits like threat modeling, it's going to be hard to automate end to end. But yeah, I'll discuss in a
but just
second.
on that point, right? The thing what's interesting is that what we also learn is that there's things you don't automate, right? There's things that you want to have change controls. You want to have dual verifications. You want to have tests. You want to have things that fail safely, right? It's not because you can automate end to end that, I think it's the difference between, yeah, we say you're a cowboy if you ship from your laptop all the way to production. Well, technically you could, right? You could say, I can automate that. But we don't do that, right? We ship it from here, and then we test, and then we dev, and then we QA, and then we push there. Like we have a whole pipeline. So I think there's a lot of teams that are trying to like shortcut like 5 steps with the Gen AI just because you feel it might work. And then what happens is when they hit the real world, it doesn't really work, or it works sometimes, but when it fails spectacularly, which is not good enough.
Yeah. So to continue on your topic on, the limitations of AppSec or even threat modeling these days is like, we have a bunch of manual processes, a bunch of complexities, a lot of manual analysis, a lot of data to actually put together. In a threat model, there's so much data that you actually need to put together to kind of solve the puzzle. There is a problem with adoption integration. There's like, fast moving, fast paced teams. It's really hard to fit it in a fast iterative environment where you ship code all the time. It doesn't scale because, you have suddenly large amounts of code that you need to analyze because there was never a security team, and it can be overwhelming. It's hard to keep up because, the code changes. So you need something that changes dynamically with the code. And it's difficult to prioritize because sometimes we kind of love to talk about all the theoretical threats. Like if you run the Microsoft threat modeling tool, you're going to get so many threats. And, people can kind of start chasing their own tail with this. So I have seen a lot of people struggle with also prioritization.
Why is this?
Why is it? Well, I think we could have a session on itself. Why is it? I think a lot of the things is like people are not looking at it from an attacker perspective. They're kind of
okay. No, but wait, okay. But you say the traditional process starts with manual analysis, and I agree with that, right?
Yeah.
But why is that? So let me think about it. Imagine you're doing a threat modeling, right, to a plane, right?
Yeah.
And imagine you get there, and what's the first question you're going to ask to them as a threat modeler, right?
Or you want some, specs of the plane. You want to see the drawings. You want to see
architecture diagrams, right?
Yeah.
You want to see details. You want to see.
Yeah.
Imagine if they says we don't
Where
do
are the exits.
Yeah, where are the exits, right? Imagine if they says we don't do that.
Yeah, I know.
Agile development, right? We just build it and we patch it, right? And look,
Yeah. That's the thing. And also,
can I chime in?
Yeah, go for it.
Yeah, but you know what you said is right for a threat modeling session, perhaps. But before everything, I want to know what that plane is supposed to do. Is it a transport plane? Is it a military plane? Because that's the kind of context that my problem with AI and threat modeling starts with. The AI threat modeling goes straight to the technical, to, as Petra said, Microsoft threat modeling tool is going to give you 300 and no context. And exactly where AI. AI so far has proven itself, to me at least, very good at giving me a more readable output than the threat modeling tool, but a very similar one. Whereas what I'm expecting you to do at some point is enrich that output and limit that output using context that only a person would be able to apply. And that's what I'm not seeing.
You need better data. You need to change the workflow.
Yeah, you need to have like the business data, like the business context. It should come if you have a tool that uses AI, or let's say that you're doing prompting, you can give it that business context, right, in the first iteration, and it knows it. Or you can even, do a threat model without the business context and say, hey, here's the business context. Now tell me what matters based on this business context. So there is ways to enrich that, right?
But the challenge here is that I think most teams, I would argue, right, some of them, they know reasonably well what they're trying to do, right? You know, usually if they have a product team is driven by the product, there's usually, I would argue that part tends to have a decent level of maturity, where it's always up to date or it always makes sense. But I think the fundamental problem here is that manual analysis that you talked about, right? That bits that are missing are nothing to do with security, right? Have all to do with development, have all to do with engineering, right? And we have to solve that, right? Or else we're just patching stuff on top.
So I'm going to be a devil's advocate now and say a developer's advocate and say, you know, diagrams don't scale. You have a diagram and it changes, and then you get another, you know, there's another one. And it's really hard to keep up and keep doing the diagrams because they need to deploy. I'm not justifying as just being you know.
No, but okay, no, you're right. It doesn't scale today. But if that diagram, if I show you a diagram from a Terraform script, right, that represents the moving parts of that, right, and you create that diagram or update that diagram on every single commit,
yeah, that's it. And I think that's kind of where I'm going to get to later as well, is like we can try to even use code to create those diagrams as well.
It's the only way to do it.
Oh, where have I seen that before?
but I'm saying we have to use reality. We have to, our threat.
Yeah, for sure.
Start with reality, right? If it doesn't start there, then it's hate-based security, right?
But what I mean by diagrams from the code is like based on the code itself of what you're building. Exactly. That's where you build a code from.
And remember, it's not just code, right? It's code, the configurations.
Yeah, exactly. Yeah.
You need to start gluing all of these, right? Because that's where you get your prioritization. You know, that's where you get context, because you start to see that this connects there, right? And all of that, right?
Yeah, no, totally spot on. I agree. It's like super powerful when you put it all together. You can even like, you know, put it into more context, as in like a cloud security and posture management tool output. Mm-hmm. And then, you know, they tend to have the attack paths concept these days.
And you know the coolest thing here? My hypothesis is that the AppSec team, I say cybersecurity, but I say the AppSec team is the only team in the building that can pull it off, i.e. connect the dots. You know why? At least to make it, because we are the only team that can speak to everybody. We are the only team that, you know, like, any other dev team, they're always going to be limited by their boundary, right? And by the politics of their boundary, right? We are the only ones that can follow the thing end to end. In fact, we're the only ones, not just from a technical point of view, can then connect to the marketing department, connect to the HR department, connect to the business requirement, connect to who's outsourcing what, who's working where, you know, are anything happening, where are the assets, who cares about the assets, right? And apply all the business layer. We can be the ones that glue that. And in fact, I think that's the future of AppSec. So when you talk about AppSec finally getting it, I think that's the sweet spot, because we have the opportunity, right? The challenge is, if we don't do this in the next couple of years, AppSec is going to be made redundant by another sector that will do this better. So a QA team will do better AppSec than AppSec in the new world. A risk assessment team will do better AppSec, right, than what we do today in 2 years from now, if we don't innovate.
All right, so maybe 2 years from now on this date, we're having another session and we're talking about it.
Yeah. No, well, I think we're going to innovate, because I think that the AppSec and the cybersecurity we're pointing in the right direction.
Yeah. So we all know what happens when these things go wrong. You know, there's no communication. Each team builds their own stuff. Because like you said, AppSec glues everything together. And then if security reviewed one feature and then reviewed another, they'd be like, oh, wait a second, you guys are building double components. You could just use one, you know?
Well, you know, the key is the worldly map, right? But I'm not going to get in there, right? Worldly maps is the answer, but we need the graphs first. But the worldly maps will be the one that puts everything together.
True, true. So maybe your next session, Dennis, is on how that's going to work in a worldly map. And, we have obviously breaches and critical things being pushed to production. So I just want to stop a second to discuss what do we expect from this tool, or like, AI generally in terms of threat modeling. We wanted to have automation. So we do want some sort of, automation, and we can talk about what exactly we can automate in a second. But obviously with the man in the loop, threat modeling is not something that I don't know. I don't think we can do it end to end as a, machine only. Actionable findings, the final outcome has to be something that we can actually action. So it cannot be abstract. It has to be quite concrete, that developers can just take away and do. And integration, we need to actually be able to use the threat model to create specific tests for our code to validate that. We can use the threat model to actually enforce the requirements. So if we have certain controls that we delegated as required, then later on, it would be ideal if that tool can actually test if this is, been implemented or not.
It's a really cool idea. That yesterday I was talking to this guy on his event, right? We were talking about the creation of worlds, right? Like simulation worlds, right? Like in a way, the idea of being able to simulate, have models of reality, right? One of the things that is absolutely going to be awesome is that imagine when you start to have these models of the applications, we can now do simulations, right? So we talk about compliance, but it's the same thing with threat modeling, right? If you have a model of an application and a model of how it works, you can now do simulations on top of it. You can write, we could have unit tests on top of that graph, right? Because that graph starts to represent the objects of your application, right? In a way, in some cases, you don't need to know how it was implemented to know that, oh, my payload goes from here to here, or this thing here has this gap, right? So it's going to be absolutely awesome to start to write tests and simulations and kind of like visualizations of what would happen here. And the other cool thing is you can put attack trees on top of it, right? So you start to see the pivoting, right? You can start to see these two worlds coming together of, well, the attack tree needs this and there's that. And then you hit here, and then what happens when you pivot, right? Which is going to be really, really cool.
Yeah. And then what are some of the challenges that we face when trying to actually, implement this? Is like, one of the things is like, it's a super complex task. Obviously, threat modeling is not a simple procedure, I would say. There's multiple parts to it. There is a lack of standardization. This is something that kind of I noticed different people see. I think we still haven't agreed completely what a threat is. I think officially, yes. But if you ask security engineers, you can still see some people putting lack of something as a threat, where a threat is, actually what can go wrong. It's not a lack of something. Lack of something could be a vulnerability or a pre-existing condition. But there is still, was a lot of attempts to standardize threat modeling, but I still think we haven't agreed on it completely. And then comprehension of the code, right? We need a developer to actually explain to us what is inside that code. How have they built it?
Not anymore.
Not anymore. Exactly. I'm getting to it.
That's a big one, right? It's a big one because remember that a lot of developers, they themselves don't know how it works, right? Because most developers that are there are not the original ones.
And also, they do small bits of it. They don't do the whole part.
Small bits, right?
Yeah.
I think you're missing a big one here that we still don't have enough good examples. Louis, when at the session on Louis,
that's lack of data sets.
Sorry?
So lack of data sets. That's it. So
okay,
good. We need a data set of threat models to be able to actually do a fine-tuned model. We don't have that. Nobody wants to share their threat models. There's not enough out there that are standardized in a standardized format. There is some examples here and there, but again, even when you look at it, it's done in so many different ways. So yes, definitely loads of lack of examples. Then you have a cost, which is essentially, all your calls to OpenAI are tokens, they cost. And you have, the famous false positives and hallucinations, which in itself is a challenge that we have to go and overcome. So these are some of the challenges. I'm not saying they're not that we can't overcome them, but they do pose an issue. So what are some of the opportunities? Like, how do I see that we could do threat modeling with AI? We could do threat modeling from attributes, which is essentially the part where we decompose the application during the threat modeling process. We essentially give the AI algorithm a lot of attributes, and based on that, it will create a threat model. I'll come to it in a second. Threat modeling from code, and also we can go even earlier in the SDLC, and when it's only in the design phase, we can utilize AI to do security design reviews, and also continuous monitoring and enforcement. So if we utilize AI not only to create that threat model, but to actually monitor that threat model for a drift, then that could be super helpful. That could be a great opportunity.
So I think here, if you go back one,
yeah,
I think you need intermediate representations, right? So when you say threat modeling from code, I think what we need to have representations or even code abstractions of what that looks like, right? And that's where you start to do the analysis, because or else in a way the code is not just too granular, it's easy to have mistakes. So my point is that if you say, here's a function, the first thing you want to do is you want to have representations of what that function is doing. And that is something that you can peer review. In fact, you can peer review, but you only do it once because you go, yeah, that is correct. Or you can even verify with tests and stuff like that. But that abstraction layer is, and I think we need better research on how to represent it. There's some guys now who start saying that if you transform some problems into mathematical formulas, you can now do much better analysis on top of that, right? So I'm not sure we go that far with this, but I think especially with code, we want to start to find these abstraction layers that represent what the code is doing. Because that means that it's like refactoring, but it will become much more solid for your continuous monitoring. Because imagine if you could say, here's an application and then it has 35 different blocks or 500 blocks who break into these 40 categories, who can now break into these 3 different main things. One of them could be security. And then we can say, any of the blocks that touches that security, we need to know. Everything else doesn't need security checks.
So yeah, I get what you mean. In a way, we can do that with RAG, but let me get to it in a second.
Yeah, actually, there's one area that I think if you're not thinking about this, which I feel that will also add a lot of credibility to us, is we especially from AppSec, we need to have an opinion on the code that doesn't matter. Right? We need to be able to start saying you can make changes to that part of the code base without any further security reviews. And you can make changes there that go straight to production. But on here, and here, not only you need more security reviews, you need assessments, and that's where you might have a roadblock before it goes into production. And we're already doing that a little bit, but we don't scale.
I think we are doing it a little bit when we're saying, you have to threat model anything that has an open attack surface, that anything that handles authentication, anything that handles PII. So we do kind of a little bit on a high level. Okay, so the threat modeling from attributes. Essentially, as I was saying before, what you can do is, the parts that compose the application, you can utilize AI to help you with that. So you have a description, a diagram. You can potentially, even give the AI algorithm a description and a diagram, and you can even get out from it. You can get the components, the storage, the data flows. You can try to extract that from there with AI. And then you can, based on that, you can do a threat model to identify and prioritize your threats, vulnerabilities, and risks. Because I think there's no point doing threats if you don't end up with some tangible risks to the application. And obviously controls out of it as well. So you need you need your threats, you need your controls, you need to figure out, okay, well, actually some of the threats have pretty adequate controls. So we're not going to say it's a risk, but there is some of the risks, and you need to implement these controls to mitigate those risks.
What's your thinking on where you store the data from one?
Where you store the data from?
Your step one.
What do you mean? Where do you store it? You mean like where do you extract it from, or?
So you create the component of the application. You have the description, you have the diagrams, you have the
Yeah.
relationships.
So that you take that from Confluence, you take that from Jira, you take it from anywhere where you store this.
Yeah, then you put it where?
You put it into a tool that has, that utilizes AI for threat modeling. So, or if you want to do it directly into your own model, you have to feed all of that information.
So that's, I think, is the single mistake that I think most people do here, is that every one of those steps has to end up in the file system. Because every one of those steps that you just described, every one of those little transformations, you have to be able to verify. You have to be able to find bugs. You have to be able to fix it, right? You have to be able to correct. And then you have to be able to diff when it changes. If you don't store it in a file system, you end up with your solution is too big, right?
Okay. So this is where we're getting at with the threat modeling from code, because this is already a connection then with the code.
Yes, yeah, to be honest, there should be a connection to the code. But my point is, these artifacts, they have to stay, right? You have to be able to store them. So when you go from one layer to the other, you just deal with the transformations there. And then you can enrich them.
This can be also a part where you don't have a code base.
That's fine. That doesn't matter, right? It doesn't matter if before it just, what's interesting about this is that at every one of those, if you do this, it doesn't matter if you got there from code or from theory or from a project or from an idea. What matters is you got, for example, a decomposition and a diagram and series of diagrams. So Izar has his hand up.
Yeah. Izar?
You had a hand up. You raised your hand.
And now lowered it.
You're high-fiving or you're raising your hand? Oh, wait. I know the problem. Sorry.
You didn't unmute him.
Sorry, he changed. Sorry. All right, Izar, off you go. Sorry.
Oh, there you go.
That worked.
I'm just here. I'm going to get him on LinkedIn. I'm going to raise my hand and lower my hand. You see, we're talking here higher level AI problems. We can't even figure out how to unmute people on Zoom.
Well,
Anyways.
I had to make a co-host.
So, Petra, this is great. Now, my question is, do you have a system that does all of this? Have you tried something like that? Do you have bits and pieces? I see the open source, the Strat GPT on the slide.
Yeah. So
where is this idea?
So this idea, I am trying. So I'm working with the guys from DevArmor, and I'm trying to do that. And I am kind of, not done with the process. It's something that I am, implementing and been iterating over. But yeah, it's not something that exists yet. I have seen, for example, other tools like Apiro. They do it from like a Jira ticket. Threat model, they do it from the infrastructure as code. So there is various types of attempts at this from different angles. I'm trying this angle, and yeah, I'm keen to see. Have you seen it?
So here's the thing. I've seen a number of tools that are approaching, as you said, from different directions.
Mm-hmm.
My problem lies in the fact that most of them are not starting from zero. They're not starting from a design. They are requiring all kinds of artifacts to be in existence. And at times they're even requiring the system to already exist. And that's when it's too late.
Can you be more specific? You mean like the inputs are already like done code or done?
So yeah, and you mentioned, for example, Terraform.
Yeah.
I have an idea. I don't have Terraform.
Yeah.
I want to talk about my idea. I want to threat model that.
So the way I'm kind of testing this is to start from the idea. It's like decomposing the application, but it can just be like a diagram that the developer created for you and saying, this is my idea. Let's threat model it.
Gotcha.
But if you have that, I think if you think of those as intermediate representations, right, with more more or less granularity. Like the C4 model is quite an interesting one, right? Where you have more or less altitude, right, or granularity. What's interesting is that you can have situations where you don't have code, or you have situations where you have code. It doesn't matter. What matters is that you then have a layer of abstraction that represents what that's supposed to do. And one of the things that would be awesome to do is to create these exactly like Izar was talking about, where you do the design phase, and then you start to measure the points where you go adrift. You measure the points where that original idea that they had, or that they thought there was going to be a way to do it, now doesn't work anymore, and the dev team is doing something else.
But the thing is, I see that intermediate formats now are the Whaley graph of this round. But yeah. My point is that even if you get to parse stuff and build that intermediate representation, a problem that I'm having, for example, with privacy threat modeling, there is a phenomenon of the oh but. I take the system, I decompose it, I create my cases, I create my abuse cases, I have this in my head, I have this intermediate representation that I can turn into any direction that I want.
Yeah.
And as soon as I start putting something in place, like, okay, this doesn't look like a threat, then I hear from the privacy expert, oh, but, and then there's another contextual thing that just surfaced because either there was some information missing or because the thought goes up to a higher level. And all of a sudden, my assumptions fall down and my intermediate representation doesn't mean anything because, again, it's lacking context. So that's the problem that I'm having with this whole AI thing and threat modeling, that I cannot shake that at some point there is something intrinsic that is conceptual here that the AI technology is just not there yet.
So I just want to kind of dig into what you just said in terms of like understand it better. So you're saying it's lacking the business context, but if the business context is there from the start, because you create, let's say, if you want to create threat modeling, if you want to create a threat model, you actually, okay, you can start from a threat model, but maybe you start from creating the image of an organization, and you kind of put all the data of what that organization does, and you give it all the data about what's the mission. You give it the data of what is the digital platform for in terms of the context of that organization, how many records it holds, what is some of the potential attackers that you think could attack based on the industry. So if you take all of this and then for every threat model that you do, you actually feed it that organizational context, is that something that would help resolve the problem that you're describing?
It would, but then it feels to me like, first of all, that's a great idea, but it feels to me like I'm creating a organizational reg assistant that's going to sit by my side while I go and threat model.
But that's the only way to scale it.
Yeah,
but at the end, you end up with Clippy poking you in the shoulder, saying, "I see you're building a threat model. Can I help you?" And we know how the thing ends.
That was just about implementation, right? Of
that. Right. But my point is that let's say that we do develop that assistant rag, okay? It won't scale to a point because you will have to at some point decide what kind of information about that organization, mission, target, system, whatever, you have to keep up to date. And things are going to change rapidly under your feet. So now the security practitioner is responsible for what? Scanning the context of the business in order to keep that rag up to date so that eventually it can help give context to a threat model?
Well, the thing is, it isn't the job of security engineers to know the context of the organization. That's like a huge part of the role. That's what Dennis was saying. A security engineer touches all the parts of the organization because you need to know all of that to be able to protect it. So if something changes, I don't know, like probably a lot of these things don't change that often, like in terms of mission. Maybe as a startup, yes, but big corps probably don't change their mission and their some of the big context that often.
They changed their strategy, and they changed the
they
tools
do.
that they
They
had
change
at
all the
hand
time,
to
right?
do that.
Absolutely.
Right?
But
So it
profile
is
of
a
the
changing environment.
doesn't change that often. Like, it's usually based on the industry. Obviously, if you start doing something else, then you add more sensitive data and you add a typical type of data. Obviously, the attackers could change.
Yeah, I'm with you.
Look, the sea doesn't change very often, but you won't find two waves that go the same way. It's exactly the same thing. The organization stays the same, but the ways that the organization does something, they do change quite rapidly.
But that's what we need to scale. I think there's one piece of the puzzle here missing, which is like, you're talking about one threat model. In my head, there are 10, they're 20, they're 30.
Oh, yeah.
Yeah.
And they connect to each other. And that's how you scale.
But
right?
also not just threat models of applications, but processes.
Exactly.
Like,
right.
you put it all together, like in a big process. Application is just part of a process, but you start with that, and you create this big monster threat.
100% agree.
But that's how that's the graph, right? The graph means that, and I think that's also how you solve the problem that you're talking, Isa, when you have a threat model and somebody goes, oh, I care about this angle, let's say the privacy angle. Then you go, cool, but that's a different threat model, right? In fact, the very technical detailed threat model provides the evidence for the one that is done with more abstraction layers to show when we say X, this is the evidence. So in a way, it should be threat modeling all the way down to the freaking code, right? But I think up until now, I could never see how this could scale because we never had a technology that will aid to us. And I don't think the solution here is to ask Gen AI to put all this together. I think Gen AI will allow us to put the bits, to understand the bits, to create transformations, to create translations that are much more effective, especially when you glue them together. But we need.
So you end up with that assistant. Yeah, I agree with you completely. Right. But my problem here is that we are building this gigantic machine here in theory, and we are just piling things and things and things that we have to put in place. And when I take that arrow to the other side, nowadays I can't get a development team to draw a freaking 4 boxes diagram. Now all of a sudden I want them to do this whole thing and keep a context up to date.
And look, I'm doing some of these, right, in some of my vCISO and vCTO engagements. The trick here is not to ask them how it works, is to show this is how your system works, right? Or this is what I'm seeing, this is what I'm observing, and then have them go, oh, hey, that's not how I think it worked, which is always interesting. Or they go, you missed this, this, and this, right? So I think the reason why it never scaled for us was that we give problems to the other side. Right? We take a team that is already massively overworked, has no spare time, can't even find time for technical debt, right? And we say, can you do these other 10 things for us? What I think we need to tell them is saying, this is how your system works. This is how we observe it, right? This is how we model it. This is your information. And then you're adding value to the system then, right? Because the cool thing is that space, nobody's at. See, so here's the thing, and I know, Petra, you're not thinking about this commercially, right? If you can tell dev teams and dev managers, right, and organizations how the code and the systems actually works, that's worth more than the threat model. And my premise here is that if you don't have that, you won't be able to do a good threat model.
Yeah.
Okay, so I disagree violently, but I want to hear Petra.
Okay, so basically this is kind of where I'm getting at as the threat modeling from code. So the way you can do that is, obviously the code is a bunch of data, it's a whole code base. And what you need to do is you need to tell the LLM, okay, first of all, what is the scope of the threat model? What do you want to find out? We expect the AI, the LLM, to know the business logic and the relationships between various code elements. Dennis was mentioning abstraction layers. Ideally the infrastructure, so maybe we give it some Terraform. So this is when we're talking about the threat model that's already created, because even though we're saying yes, it's too late, on the other hand, there is a lot of situations where you might be the first person in a company and you have a huge code base that you still have to analyze. So you will have all the code and you will have all the Terraform, and it's a huge piece of work that you actually want to kind of automate at least a little bit. So then we need that LLM to be able to standardize the threats, the risks and controls in a meaningful way. And it needs to be creative, but not too creative. You don't want it to hallucinate. It has to be comprehensive. We don't want it to miss something, but not too comprehensive. So to go back to what we were saying, this could be your, code clippy or Copilot, where you basically can understand the code with the help of an LLM, because it tells you this is how it works. You could even have a little intermediate between the threat modeling from attributes and the threat modeling from code, because you could use those attributes to create specific questions that you ask, and then you get your answers, and then you do a threat model in the end. So you use all that information. Now, how to do it? You could do it with RAG. You have, basically, I think on this call, everyone knows what it is, but for the recording, it's retrieval augmented generation. What we do is we essentially transform words into numerical vectors, and then they get grouped based on topics, and then we just retrieve them. So it's similar with code. There are certain functions and semantics that we use. We use RAG to retrieve it, and to then, because there's as I said, the code base is large. So this is kind of what we were talking before. We need to be able to know which parts of the code are related to security and which ones are not. RAG could help us with this.
RAG is another black box, right?
Say again?
RAG is another black box, and we still don't understand exactly how RAG works, right?
That's true. That's true. It needs still more work, obviously. It's not a perfect solution that I'm giving.
So I think the solution right here is not to analyze the whole code base at the same time. The solution is to go bit by bit by bit by bit, and to leave behind that abstraction layer. If you do that, that's how you scale.
Why not do it with RAG to separate it into topics?
Because RAG doesn't understand code unless you get a RAG that actually knows what Python is, right? But it's not just that. The problem is RAG is at least the ones I've seen, is a black magic, right? Like, in a way, RAG is just a way to say, instead of scanning all this code, I'm going to give you X code snippets, right? But you still don't have context, right? You're much better coming up with a code path that actually exists and taking all of that and putting it together than a RAG will do, right? The point, so I like graphs because graphs have context. So if you take the code base and you analyze it bit by bit, and you connect those bits together, then you know, right? And then you can grab that code. But if you don't do that, you don't have context again. And that's why if you look at Copilot, that's why sometimes it goes off in GitHub Copilot, then it works and that doesn't work, because they do RAG thing. So sometimes they have context, sometimes they don't have context. Sometimes they put things in there that makes no sense in that area.
I think you can use RAG, but you need to find a way to kind of, yes, like do a hybrid of what you just said, is like separate the code into elements, but I think you can still use RAG to retrieve the important information that you need from the code.
Yeah, but make it a graph, right? So not the RAG that we, like the graph RAG, right? Then yes, right? If you're talking about retrieving things based on graphs, right? Based on the structure that you want, then I think that's the way to do it, because you're not looking at the whole code at the same time.
Yeah, because I think if you first of all, you can't get the LLM to look at the whole code at the same time. But also, if you try to do that, it won't know which information is meaningful and which isn't. So hence you put it into these topics, that's why you use RAG, and it helps you retrieve it. I've played around with it for threat modeling.
Here's the question, right?
Yeah.
You start to know which part of the code don't have security vulnerabilities at all, right?
So
why analyze it?
Why analyze it? Yeah, no, I agree with you on that. I totally agree. If you isolate the parts that you think don't matter, I think that's a very efficient way to do it. I'm on board with that.
So how much do you think that will reduce the code base?
Probably 80%.
See, I think the answer is it depends on the architecture. And that's actually a hell of a metric. I think a really good metric for apps is going to be how much code we are the bat can say for this analysis doesn't matter. So the more spaghetti, the more interconnect. Sorry?
It's hard. How would you achieve that?
You achieve that because you can ask, like a simple question would be, if you have, let's say, if you use React, right? And any part of the React code base that is not using direct HTML manipulation won't have XSS.
But then you still, how do you like find that any part of the code that doesn't?
Oh, but that's easy to find, right? That's easier to find because because for example, what React made, which is a good example of a good framework, is they made it super freaking obvious, right? When you're doing direct manipulation. So this is again what I like with the LLMs is the LLMs can give you a version of the code, right? That doesn't actually exist in reality, but is a representation of that. And what that does is reduces the scope of what you have to scan. Because that's all the name of the game, right? Is to create abstraction layers. But and what I was saying before is that if you don't leave behind those abstraction layers, as soon as you try to debug anything, you're stuffed because you don't know where the gremlins are in the machine.
What if those abstraction layers change? How do you track that?
That's actually one of the metrics you want to track, because when the abstractions layers change, means the behavior of the application change.
Yeah.
And that's probably one of the moments where you do want to have further analysis or a human loop going, oh, hold on, right? My app suddenly was doing this and now it's doing that, right? Hold on, my app has 4 dependencies, now has 5 or has 20. Or now I had an attack surface that was this big and now it's that big, right? Those are actually really great metrics.
But you need a way to monitor that drift as well.
Oh yeah, all of this has to be done in a way that the analysis is done continuously.
Yeah.
None of this works if it's a one-off exercise.
Yeah.
Like this is cool. Like this is the way. But I think to be honest, I think if you're doing some research, I think you should do some research on why a lot of this has not worked in the past. Because a lot of what you have here has been tried before, especially the static analysis engines have tried to do this a lot.
Oh yeah.
Right. And also there's already a generation of LLM crowd who tried to do this. Right? I think Isai is probably a bit on that camp where he tries to feed a bunch of stuff and he fails. And I think it's important to understand, even with the latest agent stuff, why it's not scaling.
Yeah, as I said, this is a proposal. It's not an end solution. So we definitely need to be able to achieve this because that would really help us a lot. Now, the journey to achieving it is going to take a while because, like you said, maybe we need to go into the abstraction layers. I agree with the graph. If there's a way that we can use LLMs to build that graph and then to keep, the drift model even updated based on the drift from that graph, that would be the sweet spot.
I had a question for Isai, man. I don't know, maybe I didn't explain myself correctly, but if we can give the business, right, at multiple levels, a good description of how the software is working, what it does, right? Purely from a functional point of view, from an architecture point of view, don't you think that's value add? And the devs and the architects?
So, okay, I could be wrong here, but the way that I would see that kind of thing is you're basically simplifying my work of reading references, best practices, and Googling around. Because it's going to be a mechanical description of a digital system generating mechanical findings based on objective rules, which is basically what most threat modeling tools do nowadays. The value of threat modeling for me is in those eureka moments where you discover that perhaps an assumption about the system or about the design of the system was wrong, or perhaps you figure out that there is another business requirement that wasn't coded in the system and into the design, and that's when you figure out stuff. So I am less fan of, again, it's the Microsoft threat modeling tool problem all over again. You do the diagram, you put the attributes, you get 300 findings. Now go figure out what's important for you.
Yeah, but that's kind of because it's rule based.
Yes, totally. So what you're proposing
Rule-based.
here, Petra, to me would be like, wow, paradise, right? And it's great that I'm seeing glimpses of it here and there. And it's great that you are working on something that's such a pipeline. But to Danny's answer, I'm not sure, man, because at the end of the day, we keep talking about codifying the structure and extracting findings from it. As Petra said, rule based. It just changes what the rule engine is.
But I was actually talking value to the business. I was saying that going back to the question I challenged Petra before, the reason why threat modeling is still so hard and the reason why it's so art is because we don't have a standard way to describe how systems work. Our systems do not produce architecture diagrams. They don't produce, it could, in another universe, they could have done it. Maybe if the Spring framework at the time, had decided that auto-generating diagrams and documentation and structures from what they were doing, or one of the early .NET frameworks or one of the early frameworks had done that, maybe the industry would have changed, but it hasn't. So most of our tech, including the cloud stuff and all that stuff, doesn't produce representations of what it does, right? The interesting argument is that every time you go to a dev team, an architect team, or project manager and say, do you want to know how your system, first of all, you ask, do you know how your system works? Do you know how everything goes together? Usually the answer is, we don't know. Let us know if you find out, right? And you probably know that when you deliver your threat models, and the people who look at it and is very excited are actually the engineers. And they go, hey, cool, this is how it works, right? Oh, this is like, oh, I can see now the problem here, here, and here. My point is that I think, in a way, if you want to solve the threat modeling problem, we have to solve that problem in parallel. And I think solving that problem in parallel actually has a huge amount of business value to the business, and it has a lot of value to developers themselves, which actually, I think, creates a positive loop where they want to help us because we facilitate this. So we go from being a team that gives developers work to being a team that actually helps them to understand how their system works, how it operates, what are the side effects, and gets them more visibility to something they don't really have today.
But again, we are going back to that point where you need all the artifacts to be in place in order to do that amazing threat model.
Yeah, but we already have.
No, wait. You have domain-specific languages, some like SysML, that can go and be used to describe the design of a system. The problem is that to extract value from those at the level that one would expect, you basically have to write the system in that language, because only then you have all the details and all the architecture in place.
That's where the LLMs can help, because the LLMs could translate it to that system. And that's why I think, Petra, you need to think of schemas and meta languages in all of this, because that's what the LLMs are really good at. So for example, like if you have a schema for a particular layer, right, to say, if I can get to this level of abstraction, I can now do a bunch of threat analysis. What the cool thing of that is you can actually translate into that level of abstraction from an idea, from code, from different code bases, from different languages, different stuff, because now you're just describing intent, right? And that, again, that's where the LLMs are actually very good at, right? And even when they hallucinate, if you then get one to verify the other, and then you get the human in the middle, you get really good findings. And I think that solves your problem, Izara, which is you need something that works when nothing exists, and when something is half-baked, and when something fully exists. And
just make sure that if you go the way of intermediate languages, you also look at the problem of the broken telephone.
What is that?
That kids game where you have a line of kids and you tell a secret to the first one and they pass to the second one and then to the third one, and then you see what you got at the end, and usually it's something completely different.
Okay, so we call it Chinese whispers, right? Chinese.
Yeah. There you go.
Yeah, but I think the advantage here is that, especially from a security point of view, And this is where I think doing this from a security point of view has a big advantage, which is, yes, we have noise, but we tend to speak more in reality. And I think that when the devs and the QA and the architects try to do this, if you think we go over the top, dude, those guys go freaking theoretical left, right, and center, right? I think the nice thing that we have is we have the exploit, right? We have the thing to say, no. This is a problem because I go from here to there, to there, to there, and I got a side effect, right? And I think that's our advantage that will keep us real. And I think, to be honest, we were never that good at it. And I think now we really need to be good at it, which is to say, if we say something is bad, we should have evidence, right? To say why that's bad. And like, again, and Petra, that's something you need to think about how you connect the dots here, right? And that was always the challenge I used to say, you can't just say this is a problem. I want to see evidence or connect.
I agree. That's why I was saying before, you can use the findings, the controls, sorry, not the controls, the threats. You can use them to create use cases for testing, to actually prove this.
And attack trees, right?
Yeah. And you can even then, you know, even if you do a threat model from attributes, because let's say you started from nothing, you don't have a code, but then someone builds that code, you can go back to that code with just the threats. And then you can, you know, use an LLM to try validate it. You don't have to do a pen test necessarily. If you want to save time, maybe you can use an LLM and validate those threats to see if they're actually exploitable or not. Like you said, build simulations on top of that. So these are all very theoretical things now that we're talking about, right? Like, you know, building abstraction layers and doing all of these things. It'll be interesting, I think, in the next year, to see what all the stuff that comes out, because I'm sure that a lot of companies are cooking, right? I'm sure Snyk is cooking. I'm sure, you know, there is a bunch of companies that are cooking something, because threat modeling is cool, threat modeling is in, and I'm sure that there is people who want to automate it. So
Petra, I can give you a project. Sorry, how many more slides do you have?
Right. Okay, RAG, we spoke about it. And, you know, what we want, I think we spoke about the Brave New World a lot. You know, as I said, autonomous AI agents are emerging markets. Let's see what happens with the threat modeling agents. And what I want to do is I want to create an OS project that will then entail defining a threat modeling schema, basically a JSON schema, and then getting a bunch of threat modeling examples, open source, so the community, everyone can use it. And that way we at least resolve the problem with a lot of examples. And maybe that can help us bridge the gap. And maybe that can help with Ether's problem of, you know, having robotic automated responses, because if we have actual real threat models that, you know, people have built and have submitted, and, you know, with descriptions of the system, all the attributes, and then all the threats and all the controls that they recommended, obviously PR reviewed before it goes into the data set and all of that. And maybe we can get to this brave new world that we are talking about. So yeah, that's kind of what I want to do. If I'm hoping to create a OS project soon. And if
I mean, count me.
Just create it, right? Like, this is not, you don't have to ask permission, right? Like,
no, I did it. I mean, I submitted it. It's pending approval. It's submitted. So I didn't ask for permission. I did it.
What did you call it?
Oh, now I don't remember.
There are a couple that I've been trying to do that in the past, right? Have you seen that?
Okay. Hold that thought.
Actually, there was a cookbook thing.
I know.
It still exists.
Yeah, it still exists. Yeah,
that's another cookbook project. You might maybe take over that one. Look, it's 3 years old. Actually, have you seen it?
No, but it's not. It's not comprehensive. I looked at every single threat model in there, and it's.
Create a new one.
Yeah, I'm going to create. Maybe we can utilize partially to do what we want to do, but it's not going to be like, you know, something.
Look, Zoe and Jonathan are really, really open to input. So if you want to talk to them and move the threat,
talk to those guys, right?
Way,
you're right. Yeah.
They're awesome.
Okay, cool. I'll talk to them.
could fork it, right?
They're the leaders of the threat modeling cookbook, right?
Yeah.
Yeah.
Yeah. Oh yeah. Okay. Cool.
Let
Yeah.
me say one quick thing. So I have a project, if you want a threat model, which I think really shows the two worlds. Can I show one thing?
Yeah. Let me just see if I'm done with my thing. All right.
And Petra, so first of all, thank you so much. This was really nice. If you manage to move this forward somehow, I think you should present at Threat Modeling Con in Barcelona.
Yeah.
And you would find a lot of people wanting to work with you on something like this.
You mean for the threat modeling data set?
Also, but for the system at all, the end-to-end thing.
Okay.
You would find a lot of likely-minded people that would be interested in
When is the next one?
This.
That the guys that were happening in Lisbon too, right? Early on, wasn't it?
We had one in Lisbon and one in San Francisco last year.
Yeah.
This year it's going to be Barcelona and DC.
When in Barcelona?
Barcelona, I think it's April, end of April. I remember it's right after OWASP.
Okay. Is it after OWASP or before OWASP?
The day after.
Yeah.
Ah, okay. Then it's in May because I thought OWASP is in May. I think.
Yeah. No, it's. I think that OWASP is April end, and then ThreatModCon gets into May.
Okay.
Petra, can you? I'll just do this quickly, and then we wrap up. Can you see this? See this fast API?
Yeah.
So this is a good example of, so the interesting thing is to do a threat model between this fast API and this one, right? And they both give the same data, right? For example, a feed from, in this case, Hacker News, right? You could see there's a nice JSON file there. There's a nice, again, actually that's the cyber boardroom, sorry, this one here, right? Feed data, same thing, right? So the difference is this second one, I'll show you the mode. This second one is, actually the original one is, it has a typical fast API, and the second one just uses CloudFront and S3 bucket. And look, read these two blog posts. I go into detail on the logic and why I did it and why I did it and all the stuff. The coolest thing, right, is I then did a stride analysis on this, right? So I did an analysis on between the two modes, and here's the cool analysis, right? Where in the S3 API driven versus the fast API, I basically, and I please challenge this, right? Please, Isa, I would love to get your feedback here, because I actually did just about 80% of this on Claude with my coaching, right? But 90% of the content and the stuff was created by Claude, right? I agree with it, right? But I would love to see where I basically mapped that in that second architecture, the strides, 4 don't exist. 1 is by design, and the other one is low. And then I mapped the OWASP top 10, same thing, 4 by design, and I put an asterisk there to say, I'm assuming that you don't have a 0-day on S3, right? Or you haven't compromised a key, and again, that's a different threat model, right? So here's a good example of 2 different systems that have very different architectures, right?
Yep.
The coolest thing of this is the fast API is the traditional API that you expose stuff. And I actually arrive at the other one in the mix of security and engineering by trying to refactor, and reduce threats. But look, Petra, this is all open source, right? Let's collaborate on this, right? Because this will allow us to have real, and this is a real stuff, right? This is a real app, it's going to be, starting to be used in production, and it's actually provide a really cool service, right? To provide news feeds, right? But I kind of love this view that I was able to create, and these threat models that I was able to map out, right? That gives me this view of dramatic risk reduction, right? And dramatic sort of like analysis. And then in the end, I got, Claude to give me these cool diagrams, which are actually all spot on, right? And that's even those 2 are a good example of the difference of risk from one to the other.
Yeah. Is this something you posted on LinkedIn recently?
Yeah. So let's elaborate on that one, because I feel it's a really cool real world project, right? That is actually, so basically I did it because in the cyber boardroom, I want to have personalized news feeds, right? And I realized that every freaking body has RSS in 2024. It's like, what the hell? So I basically had a service that goes and gets the RSS and puts that into JSON files that you can then consume. right? So and in fact, I have that now for the summit content, right? Which is really cool. So you can ask questions about the content. So that's a good example of a reasonably complex API with functionality that we can now use, and so I'm volunteering this, right? But also I want to have this part of the pipeline, and I want to have real-time threat models created on that app, especially when you can show side by side the difference of architecture, right? And the thing that I really want to show is that the main advantage on the S3 is actually technology and business, but security drove that decision. But I have a solution that now scales as much as S3 scales, right? And from a cost point of view, whatever that will cost will always be 10x costs to do the same thing on Fast API. So it's a cool example of security driving business benefits, right?
Yep, definitely.
But it's a real world architecture, right? So cool. So let's collaborate on that.
You asked me the project name, Threat Model Vault.
Ooh, we need a better name than that.
Oh, thank you, Dennis.
Sorry, because it's not a vault, right? It's not a secret. A vault is a secret, right? It's like a code base. It's like a library.
You want something open, yeah. You want the idea of
That's
openness.
a good point.
Sorry, just say
okay, point taken, point taken. I can change the name. It's not set in stone.
Sorry, just that my
But
first.
that's the one that you sent into the request?
Yes, yeah.
Okay.
Yeah, I was told I think at the end of December that it will be decided if it's approved or not.
Yeah, well, let us know if there's any problems, right? But there shouldn't be any problems. But the best thing to do is you start, right? Like there's nothing reason to start.
No, I have started already.
I have a repo called OWASP, but it doesn't matter.
Yeah. No, I've started already. I'm just, once I get the repo.
Think of Vault. This is where you should have gone to ChatGPT and say, give me some name suggestions.
Well, I'll be very honest. I did go to ChatGPT. That's why I don't even remember it, because it was like a thing that I needed to do. Actually, are we still recording or not?
Yeah, we're still recording. Let me end the recording. Right, this is a great session, right? Again, and the coolest thing is I want to see if we're going to extract the transcript so we can finally be able to have a chat with the session and get people to say what's interesting about this, right? Because
that'd be nice.
We go on tangents. So somebody could say, ignore everything that Dennis said. Let me just listen to what Petra said. Right?
And then I want you to put all the transcripts together, and we can start seeing who agrees with whom and connecting those dots.
Yeah.
Make a theme.
Exactly.